Hello guys, welcome back to my YouTube channel. Today I'm going to show you something really cool. It's called NUTRIGAZE, a deep learning project that helps detect rotten fruits and veggies. Whether you are into AI, food tech or just curious how it works, stick around. It's going to be worth it. Now let's take a look at some practical features where NUTRIGAZE can make a real difference. This is the basic user interface. This is the basic matter about NutriGauge, and this is the main feature of our application, that is predicting the rotten veggies and fruits. This is basic contact page and a simple nav bar. So our simple application is mainly based for AIML, small projects. Shall we go and see the implementation of the project? Let's go. So we have trained our model using Python, and the code for training is written in Jupyter Notebook. So first we have imported all the basic modules into our Jupyter Notebook. After that, here we want to download the Kaggle dataset so that the accuracy will be good. In order to download that, first you need to upload your Kaggle profile or your Kaggle API token, and that is done using this. After that, you can download any dataset in the Kaggle. Since it comes in a zipped format, I have unzipped it. Now we will see how the data is present in our dataset. After that, we divide them for training datasets and test datasets. These are all the classes that we have in our dataset. So we have included image size and image data generator so that the accuracy will be good. Followed by all the content in order to train our model. And to see if it's working or not, whether the dataset is correctly linked or not, we have loaded a few sample images. So once you have got a clarity on your model, then we have passed it to the next phase, that is testing. So we have downloaded our VGG model, and these are the basic data about our model. We have flattened the output and converted into dense using softmax function. And after that, we have created our model. And this is the overall summary of the 19 layers present in our model. And last but not least, here comes the major factor affecting our model, that is approaches. Based on the number of approaches you run and the steps by each approach, the accuracy of your model will greatly be affected. Here I have just limited to small steps per approach, that is 20. You can go to the large amount present in it, that is by default. So in our dataset it's 168. Since it's sample project, I have limited it to 20. And next we have predicted the values of output for one of the image so that to see how our output is generated. This will be useful when we want to connect it to the front end. And at last, we have saved our model. In order to get it into our local storage, we will download our model. So this is guys. Now let's go to a front end. So now we are going to see the project model structure. So we have basically three major folders. One model where we have downloaded our Keras model and the static folder. This static folder is used for keeping our CSS files or the uploads. In templates, we have seen, as I have shown you, it's a single index.html page. So now let's see the code. The major part in our front end or the code that we are doing is to connect it to the model. So that is done using this app.py folder. And first, as I've already said, we are importing the models that are required to us, that is Flask, so that we can run our model in the front end, and TensorFlow models. This app.py file runs a Flask application and loads the trained model to make predictions based on user upload images. So as I've shown you, these are the 28 classes present in a model. This is to get the image uploaded by the user, and then we will re we will give the output to the user, that is whether it is rotten or not. So based on the predictions, that is the data given by it, based on that array that I have showed you earlier, we will classify it whether it is healthy or in rotten. At last, we will run our model using app.py. Now let's finally see how our application is working. Yeah. Now we are going to choose a file so that it would protect. Let's go. Yeah. Let's see what a model says. Here you go. You got that these vegetables are fresh. Let's try a few more cases. There it is. Now let's see some rotten cases. Shall we see one more? Yeah. We could say that our model is working perfectly because even the small changes in grapes have been identified as rotten. So this is guys, you can basically develop the small projects in AIML which you can add to your GitHub account or your portfolio, and you can also enjoy the process like I do. That's it, guys. I'll come back later with another interesting video. Thanks for listening.